Hello future pilots, let's start the next chapter of instrumentation, which is the gyroscope. So the first question that should come to your mind is that what is a gyroscope? A gyroscope is a spinning device that maintains its orientation in space, provides a stable reference for aircraft movement, and remains unaffected by roll, pitch or yaw changes. So let me explain you with an example. So with a real life example, I will explain you. So this is a toy we have all played with this before, right? So when it spins, if you remember, it used to stay upright. But as it slows down, it used to wobble and then it used to fall. So we can say that when it is spinning, it used to be stable and it does not want to fall. So gyroscope is very similar to this. As it that was also spinning and gyroscope also spins. Like you can see, it is a spinning device. So this is the rotor which spins. And as it spins, it maintains its orientation in space, just like this spinning toy. It used to maintain its orientation, but as it slows down, it used to fall. So I hope you understand what is a gyroscope now. So what are the uses of gyroscope in aviation? So this is the six packs and three of them uses gyros, which is the first one is the attitude indicator, which shows aircraft orientation. Second one is the DGI, which is the directional gyro, which provides stable heading. And the third one is the turn coordinator, which indicates rate of turn and roll. Alright. And with that, gyro compass and INS-IRS, which provides navigational reference, and autopilot and yaw damper, which maintains aircraft stability, also uses gyroscope. So pilots rely on gyroscope in their instruments to know the plane's position. Even if they can't see outside, these gyros tell them if they are turning, climbing or flying straight. Alright. So all of this rely on the gyro's ability to remain aligned with while the aircraft moves around it. Alright. So now we know where gyroscopes are used. The next we're going to study about the structure of a gyroscope. A gyro consists of a spinning rotor mounted so that it can freely rotate about one or more gimbals. So let me explain you. So gyro, you can see, so this is the rotor which spins and it is mounted in two ways. So there are two, horizontal axis gyro and vertical axis gyro. So as you can see here, the spin axis is horizontal. So the spin axis lies parallel to the earth's surface, right? Next is the vertical axis gyro. The spin axis is vertical and the rotor is spinning like this. So the spin axis points vertically. So now we're going to study about the two fundamental properties of a gyro. The first one is the rigidity in space. So let me read this. When spinning, a gyro's axis tends to maintain its position in space. This happens because of angular momentum. So let me explain you with an example. So when you ride a bicycle, what happens is, if you, for example, you are riding a bicycle and then the wheel is not moving. So what happens is, and you try to balance the bicycle. So what happens is the bicycle will fall and eventually you will also fall, right? But what happens when you ride the bicycle and you pedal it? The wheel of the bicycle also moves, right? Also rotates, which will make the bicycle more stable. And as we increase the speed of the bicycle, what happens is it becomes more stable. And now you will not fall because it resists from falling. So this is the rigidity. So when spinning, a gyro's axis tends to maintain its position in space. Alright, I hope you understood this. Next is what are the factors which affects rigidity. So there are three factors. First is the rotor mass, the radius and the rotational speed. Alright, so heavier rotors are more stable. So if the rotor is more heavy, that which makes it more stable. Alright, and thus increasing the rigidity of the gyroscope. Next is the radius. So if we increase the radius, so a larger disc increases the moment of inertia. So if we increase the radius, what will happen is it will increase the moment of inertia, which will make it more stable and thus it will increase the rigidity. Next is the rotational speed. So if we increase the speed of the rotation, what will happen is it will increase the angular momentum and thus the rigidity will also increase. So let me explain you. So when we ride a bicycle in a slower speed, it is less stable. You have realized it, right? If you like pedal it very slowly, what happens is it tries to fall, right? You have to balance it by using the handle, right? But when the cycle is at a higher speed, meaning the bicycle wheel is at a higher speed, you have to give very less control to the handle, right? So we can say that as we increase the speed of the speed, it will increase the stability and thus increasing the rigidity. Alright, I hope you understood this. So what are the ways to increase rigidity? Use heavier material for the rotor, so it will make the rotor more heavy, right? Use increase rotor diameter. Increasing the rotor diameter will make it more increase the moment of inertia, which will increase the rigidity. Position most of the mass near the rim. So as you can see in the bicycle example also, that most of the mass, most of the weight is at the rim, so it will make it more stable, right? So it will make it more rigid. Next is spin the rotor at a higher speed. Now we know that if we spin the rotor at a higher speed, it will increase the stability and thus increasing the rigidity. The second fundamental property of a gyroscope is precession. So let me read this. When a force tries to change a gyro's orientation, the effect doesn't appear where the force is applied, but 90 degrees ahead in the direction of rotation. So what does this mean? So let me explain you by this. So as you can see, a force is applied in this direction, but the effect is 90 degrees ahead in the direction of rotation. So this is what we call as precession. So if you try to turn the spinning wheel, it won't turn where you push, but 90 degrees ahead in the direction it's spinning. Alright, so by this two example I will explain you. So when the gyro is stationary, what happens? So that means that the rotor is not rotating. So when the rotor is not rotating and if we apply the force in this direction, the effect will be also in that direction only. But it changes when the gyro starts rotating. So as you can see, the rotor is now rotating. So when we apply the force in the same direction as when the gyro was stationary, it is applied 90 degrees along the direction of the spin, as you can see. So this is the rule of precession. A gyro reacts to an applied force at a point 90 degrees later along the direction of its spin. So this is what precession is. So now we know that precision is actually opposite of rigidity, because a more rigid gyroscope will precess slowly and a less rigid gyro will precess quickly, as it is written here. So what are the factors precision rate is depends on? So the first factor is the magnitude of the force applied. So more the force applied, more is the precision rate. And it also depends on the gyro's mass and spin speed. As we have already read that if we increase the mass of the gyro and the spin speed of the gyro, the rigidity increases, right? And we know that rigidity is opposite of precision. So we can say it is inversely proportional in this case. As we increase the gyro's mass and the spin speed, the precision rate will decrease. Alright, so in order for the gyro to maintain its axis, we have introduced gimbals. So what are gimbals? As you can see from here. So gimbals are like rings that holds the spinning wheel. They let the wheel tilt smoothly in different directions. Alright, so there are one gimbal and two gimbals. One gimbal gives one axis movement. That means that it lets it turn side to side. And two gimbals allow full freedom. That means it let it move in any direction, up, down, left, right, so it can keep pointing the same way even if the plane tilts or turns. Where it is used? It is the one gimbal is used in turn indicators, and two gimbals which give full freedom, it is used in artificial horizon and the directional gyros. So you have to learn this, and most of the questions come from this part. So now we're going to study about Gyro Wander. A gyro does not stay perfectly aligned forever. Its spin axis slowly drifts or topple, and this is called wander. So let me explain you. Gyro slowly drifts or topple over time due to imperfection and the Earth's rotation. So let me explain you with a real life example. So just like a spinning top that we have already studied, that toy which spins, it eventually wobbles, right? Or a Beyblade, if you have played, it eventually wobbles and it falls. So just like that, gyros are similar. So gyros slowly drift from their true position because of tiny imperfection and the earth's rotation. So it depends on two, real wonder and apparent wonder, or a combination of both. So first we're gonna study about real wonder. So real wonder is caused by imperfection within the gyro. So there are three factors, which is imbalance in the rotor mass, imperfectly balanced gimbals, and uneven rotor bearing. So you have to learn this, what causes imperfections in the gyro, which causes real wonder. Alright, so these are the three factors. And what is apparent wonder? Apparent wonder occurs because of the earth is rotating and the aircraft moves across its surface. So as the earth is also rotating and the aircraft also moves across its surface, there's a error which it causes. So it is divided into two, earth rate and transport wonder, that we will study now. So what is earth rate? Because earth rotates at 15 degree per hour, a gyro fixed in space appears to change direction relative to the ground. So a gyro which is fixed in space, it appears to change direction relative to the ground. So let me explain you by this two example. So this is an aircraft that is parked in the northern hemisphere, which is pointing true geographic north. And also the spin axis of the gyroscope is also aligned in the same direction. And now if we attach a compass to the spin axis, just like we did here, we will see that as the earth is rotating, we know that the earth is rotating at a 15 degrees per hour. So as the earth is rotating on its own axis, the gyro spin axis still remains in the same direction in the space. So we can see that the direction of the true north in relation to our gyro north appears to decrease in degrees, like you can see in the northern hemisphere. So we can say that there will be always a decrease in northern hemisphere, and for this reason the earth rate is designated negative, like here, and the opposite in southern hemisphere, it is positive. So there is a formula of earth rate, which is 15 into sine lat per hour. Why it is 15? Because earth rotates at 15 degrees per hour and into sine lat per hour. So the effect changes with latitude. So as we change the latitude, like in northern hemisphere and southern hemisphere, the effect changes. So when it is at equator, it is zero. The earth rate is zero at the equator, because if we put the value of the latitude, which is 0 degrees in the equator, so 15 into 0, which will make it the earth rate 0, right? And which is maximum at the poles. The earth rate is maximum at the poles because we are going to put value 90 degrees in the sine. Sine 90 is 1. That means that the earth rate is 15 degrees at the poles. So it is maximum at the poles and least at the equator. So what is transport wonder? It occurs when aircraft move east or west across latitudes. The curvature of earth makes the gyro heading appear to change. So let me explain. So when flying easterly or westerly, your gyro is moving across earth's curved surface, right? It is moving across earth's curved surface. So to an observer, it seems to change heading, as you can see. And this is what transport wonder is. It seems that the gyro's heading appears to change. So when flying easterly in the northern hemisphere, it produces negative drift. As it is written here, in northern hemisphere, in east, it produces a negative drift. So that is the reason it is negative here, over here. And when moving westerly, it produces a positive drift. And this is the reason it is here plus, with a plus sign. And it is opposite in the southern hemisphere. So in east it is positive and in west it is negative. So you have to learn this. So what is the formula of transport wonder? The formula of transport wonder is easterly component of the ground speed divided by 60 into tan lat per hour. You have to learn this. And so we can say that the faster you travel or the further from the equator you are, the stronger the effect is of the transport wonder. Because if you are at the equator and tan 0 degrees is 0, so the transport wonder, there will be no effect. But as we go further from the equator, what happens is that the effect becomes more stronger. So what are the types of gyro by function? So there's displacement gyro and then rate gyro. So let's talk about displacement gyro. So these gyros measure angular positions like roll, pitch or heading changes. So this is the reason displacement gyros are used in DGI, which is the directional gyros, or the artificial horizon, because it can measure the angular position like banking and pitching. Alright, next is the rate gyro. Rate gyro, from the name itself we can understand that it measures the rate of angular change, such as rate of turn. So it can measure the rate of turn. So this is the reason it is used in turn coordinators or turn indicators. Now you can see that displacement gyro are divided into two, space gyro and tight gyro. And under tight gyro there's earth gyro. So let's read what is space gyro. So it is free to move in space without external restoring forces, prone to drift and mostly used in advanced systems like inertial navigation. So space gyro are used in INS, which is inertial navigation system, and these gyros have two gimbals. That means it has 2 degree of freedom. Alright, next is the tight gyros. These are held or tied to an external reference like the Earth's horizontal or vertical plane. So it is tied to the external reference like Earth's horizontal or vertical plane. So where it is used? It is used in the directional gyro, which is the DGI. And this also has two gimbals. That means it has 2nd degree of freedom. Next is the earth gyro. Earth gyro is a subtype of tight gyro, as you can see. So where gravity maintains orientation. By the help of gravity, it maintains its orientation. And it is used in artificial horizon. Alright, so this gyro is used in artificial horizon. And this gyro also has two gimbals, and that means that it has 2 degrees of freedom. Next, in rate gyro only have one gimbal, because it just have to show the rate of turn. So this is the reason it is used in turn coordinators or turn indicators and have only 1 degree of freedom. So in summary, I have already written all of it, and you just have to learn this part because this is the most important and most of the questions come from this part. Next is classification by construction. So there are 3 classifications: tuned rotor gyroscopes, ring laser gyroscopes and fiber optic gyroscopes. So let's read this. Tuned rotor gyroscopes. Traditional style with a spinning disc rotor, widely used in many aviation instruments. So all the instruments, we were already studying about this because this is a spinning disc, which is the rotor which was spinning, right? And we're going to study about this classification of construction, right? Next is the ring laser gyroscope. It, from the name itself, it uses laser beams traveling in opposite direction within a prism. This detects angular velocity changes without moving parts. Alright. Next is the fiber optic gyroscope. Employ fiber optic cables to measure rotation using interference of light based on similar principles to RLGs used in advanced modern systems like the Airbus A380. So it was first implemented in the Airbus A380. Alright, so we are only going to study about the tuned rotor gyroscope. So what is the power source for tuned rotor gyroscope? So there are 2: pneumatic power, and the second one is the electrical power. So it is powered by 2 sources. So pneumatic power utilizes vacuum or low pressure to spin the gyro rotor by drawing air through the instrument. Common sources include engine driven vacuum pumps, manifold suction or venturi devices outside the aircraft. Pneumatic gyros are advantageous as they operate independently of aircraft's electrical system, protecting instruments during electrical failure. So let me explain. So pneumatic power works by making a lower pressure at there. So if there's a lower pressure, we know that the velocity of the air will be more, and by this air pressure, this gyros work. But from where this air comes from? So the sources are engine driven vacuum pumps, manifold suction, and venturi devices outside the aircraft. But how is pneumatic power source better than electrical power source? Because during an electrical failure in the aircraft, the pneumatic power source gyros will still work because it does not depends on the electricity, right? Next, which is the more better source, which is the electrical power, powered by an alternating current motor integrated with the gyro rotor. If supplied by direct current, an inverter converts into alternating current. Electrical gyros reach operational speeds quickly and maintain consistent rotor speeds for accuracy, and can be sealed against dust, moisture, and durability. So this is a better power source for tuned rotor gyros because it can reach operational speed very quickly, because it is by electric, right? So it is more consistent also, and thus the accuracy is more. And because there is no involvement of the air, so it is sealed. It is sealed, and so there won't be any dust or moisture which will be affecting the gyros. So it is more safer. Next is gimbal systems and degrees of freedom. So what is gimbal system? So gyros are mounted in gimbals to allow the aircraft to move freely while the gyro maintains orientation, right? We have already know this, that the gimbals are the rings that are fitted in the aircraft, so that the gyros will stay in their orientation, but the aircraft are free to move, right? So there are two gimbals. So this gimbal is called the inner gimbal, which one gimbal means only it provides 1 degree of freedom, allowing the gyro to spin on its axis, right? And the outer gimbal, which is the second gimbal, and which gives 2nd degree of freedom or all freedom. So it allows the gyro to remain stable. The gyro will remain stable, but the aircraft can pitch, roll, or yaw. But the gyro will stay in its orientation in space. The spin axis itself is not counted as degree of freedom. So this is the end of the chapter. You can get these notes in the description itself, and thank you for watching.